Next case, as a second case, I'd like to show the Parkinson case. Basically, the patient is the 56 years old female subject. This subject has the Parkinson disease caused by medication side effect, basically, because she has originally paranoid type schizophrenia disease. Basically, the excess of the dopamine receptor in the striatum is reported in the schizophrenia. So the patient originally has a long-term schizophrenia medication. The medication down-regulates dopaminergic system. Long-term dopamine suppression medication eventually deplete the dopamine in the striatum and cause Parkinson disease. This is often called it as secondary Parkinsonism. She shows very diseased facial expression and poor motor coordination. Basically, he had originally schizophrenia, and secondary she had a Parkinson disease. She has a medication of antipsychotic, anti-Parkinson, and also tranquilizer. Her QEEG main finding is the frontal theta rhythm, and we can see together in the iSync brain site. Basically, I can navigate I can navigate her EEG here. This is the her EEG, basically, and this is the raw data. We can see you can see a lot of theta rhythm here. This is the alpha activity in the back of the head, a lot of theta activity in the frontal area. And we can easily find the slow activity in the frontal area. Like this. This is another slow activity in the frontal area. Another slow activity. And we can find another slow activity. Continuously, we can find the slow activity like this. This is the frontal theta. Basically, dopaminergic problem. In this case, the raw data is quite clean, and the clean data is also, you can see in this case, raw data is a referential montage, and the clean data is common average montage. More easily, we can see the slow wave rhythm in theta rhythm here. You can more easily find the theta wave, I think. This is another theta rhythm here. And this is another theta rhythm here. This kind of theta rhythm in the frontal area like this. This is the alpha activity, and frontal theta is the main finding for this Parkinson disease. In this case, we can see the components again. The first component is the alpha activity from cuneus. Basically, peak frequency is under 10 Hertz, but alpha goes to the mid for example, 12, more than 12 hertz. Basically, her alpha frequency is a very wide distribution from low 10 hertz to the in this mid 15 hertz. Very wide distribution, basically kind of overarousal here. Basically, she is a slow alpha peak frequency and a high alpha peak frequency together. At the same time, slow alpha and high frequency alpha. The alpha activity itself means the kind of overarousal in this case. And the frontal theta rhythm is this frontal theta rhythm well explain her Parkinson symptom, basically. And there is another slow theta rhythm in the frontal area. Another theta rhythm in the left frontal area. So we can, she also has a kind of theta rhythm in the precentral area too. Basically, a lot of theta and alpha and beta activity at the same time. Very complex EEG sign. Basically, I think she has a high-speed alpha frequency coming from her psychotic symptom and the slow frequency activity in the frontal area coming from the dopamine down-regulate medication of the for relieving the schizophrenia symptom. But long-term medication made the dopamine depletion. So finally, she has the frontal slow rhythm, make her facial expression very rigid and motor coordination very poor. In this case, basically the most significant abnormality in the frontal theta activity, and basically the alpha frequency is very high. In both together, combine this slow activity and high frequency overarousal pattern is the typical for this secondary Parkinsonism. Very slow activity is excessive, and alpha activity over 12 hertz is excessive too. And in the relative power, there is a frontal theta activity excess, and the posterior alpha activity is excessive too. This is the typical pattern, and we can also see the slow activity in the frontal area, and also see the high frequency alpha activity in the back of the head. Very wide alpha distribution. In this case, 13 hertz is excessive. And there are a lot of alpha peak here from 8.5 to maybe 13 hertz here. And there are slow wave activity in the frontal area is the main finding for the Parkinsonism. At this point, I'd like to introduce Parkinsonism. You sometimes accompany in this slide another Parkinsonism. Sometimes Parkinsonism accompany cognitive decline, Parkinson disease (MCI). Sometimes Parkinson disease dementia. We can compare both EEG, Parkinson disease, without cognitive decline and with cognitive decline in this slide, and Parkinson disease with a cognitive decline shows more slow alpha activity here, This is the 8.5 hertz. This is the 7.8 hertz. So the Parkinsonian case and this Parkinson disease with cognitive decline, both cases shows underactive phenotype, basically, for the Parkinson symptom. But the Parkinson shows overactive phenotype in this case. Some Parkinson disease, in this case, tremor-dominant Parkinson disease, shows the overactive phenotype. So in the ADHD case, there is the underactive phenotype, and also there are overactive phenotype. In the Parkinson disease, there is underactive, and also there is overactive phenotype like this. So we can design different intervention based on the EEG phenotype.